ओके. सो आपला आजचा टॉपिक आहे न्यूटन्स लॉ ऑफ विस्कॉसिटी. न्यूटन्स लॉ ऑफ विस्कॉसिटी. फर्स्ट ऑफ ऑल, व्हॉट इज मीन बाय अ न्यूटन्स लॉ ऑफ विस्कॉसिटी. आपल्याला सगळ्यांना माहिती आहे विस्कॉसिटी काय. इट इज रेजिस्टन्स टू शियर. द मटेरियल हॅज अ प्रॉपर्टी टू रेजिस्टन्स टू शियर. When in the case Newton's law of viscosity states that Newton's law of viscosity states that the stress of fluid layers is directly proportional to the rate of shear strain, means tau is directly proportional to du dy. In the case of liquid, when it flows, it means it shear layer to layer. ओके, म्हणजे काय होतं की प्रत्येक जो लेयर आहे तो एकमेकावर शेअर करत चालतो. सो दॅट्स वाय दी shears is happen on between layers and it will be flows. So that is the Newton's law of viscosity states that tau is directly proportional to du by dy. So dynamic viscosity. Dynamic viscosity is defined as measures of fluid resistance to flow one layer of fluid over the adjacent layers. आता जर समजायचं झालं तर व्हॉट इज मीन बाय अ डायनॅमिक विस्कॉसिटी. यू सी अ फिगर. ओके, इथे एक फिगर आहे बघा. सो इफ liquid flows on a fixed plate or a fixed surface that is flowed on the fixed plate. So when at distance at y there is a one layer which flows with the velocity u, and at the y plus dy at the height that flows with the velocity u plus du. Means what, की पहिला जो लेयर आहे तो वेलोसिटी u ने फ्लो होतोय आणि जो सेकंड फ्लो आहे किंवा जो वरचा जो फ्लो आहे तो u प्लस du या वेलोसिटीने फ्लो करतो. सो इट मीन्स there is a different velocities of flow or different layers. So as we, this is with the velocity u and this with the velocity u plus du. As we know that the shear stress, Newton law of viscosity, is proportional to the rate of change of velocity. So it's tau is du by dy. Hence here mu is a constant of proportionality, and that constant of proportionality is termed as a dynamic viscosity. So unit of dynamic viscosity is Newton second per meter square in SI system. In CGS system, it is a dyne second per centimeter square. One dyne is called as a 1 poise, and 1 poise is a 0.1 Newton second per meter square. किंवा 1 Newton second meter square is equal to 10 poise. Is like the way that. So as we know that tau is direct du by dy, and mu is the constant of proportionality. So what is mean, tau is what we mean shear force, and du is the velocity and dy is the depth. A shear force is a measure in Newton per mm square. Velocity is measured meter per second and depth is measured in meter. So 1 Newton per mm² is nothing but 1 Pascal, and here meter, the here this meter and this meter is get cancelled with each other, so 1 upon s is remain. So mu is measured in Pascal into second or Pascal dot seconds. In the like way that dynamic viscosity has a unit Pascal second, or it will be Newton second per. So here viscosity of some common materials. There are some fluids are the gases and the liquids. So hydrogen has a viscosity as like is shown in your screen. You can see that the different viscosities for different gases and same as for different liquids. So we can measure a viscosity by viscosity Seebolt viscometer, Reynolds viscometer and all that instruments. The next is a kinematic viscosity. It is defined as a ratio of between dynamic viscosity and density of fluid. Means it is a dynamic viscosity upon the density, that is a mu upon rho. So its unit in SI system is a meter square per second, and in CGS system centimeter per second. 1 centimeter per second is known as also a stroke, and 1 stroke is 10 raised to minus 4 meter square per second. So in the way like that, the kinematic viscosity we can solve or find out. So take one problem you can write in your notebook. So the problem we can solve: a fluid with absolute viscosity of 0.98 Newton second per meter square and kinematic viscosity of 3 meter square per second. Determine the density of fluid. So you can take one pause and use the formula we seen in above PPT or above slide. So take we calculate the solution. We have given that absolute viscosity mu is 0.98 Newton second per meter square, and kinematic viscosity is 3 meter square per second. So as we know that the formula mu upon rho, so the density is given by this formula. So kinematic viscosity we know that 3 meter square per second, and viscosity is 0.98. So we can calculate with the putting these values in the formula. So you can calculate on your calci also. So our answer is 3.0612 kg per m cube. So therefore the density of fluid is what? 3.0612 kg per meter cube. Same the way we can take another one problem. A plate of or a plate 0.050 mm distant from fixed plate moves at a 50 centimeter per second, and it required force of 3 Newton per unit area, that is 3 Newton per meter square. To maintain the speed, determine the viscosity of fluid, or determine the viscosity between the plates. Okay, we have to calculate this problem. You can take one pause. You know the formula which is taken in a above slide. Okay, so we can calculate the solution. So depth, or the distance is 0.05, so 0.050 mm, that is zero point 0.5 in meter, that is 0.05 into 10 raised to minus 3 meter. And in the case its velocity is a 50 centimeter per second, so 50 centimeter per second means zero point 0.5 meter per second is the speed of that. So shear force we know that is given, that is a 3 Newton per meter square. As we know the formula, tau is equal to mu du by dy. As du is a change in a velocity, means final velocity we have get minus the initial velocity. We know that the final velocity, that is a zero point 0.5 meter per second, minus initial velocity of the fluid is 0. So it its velocity is a change in velocity is 0.5 meter per second. Change in distance, as we had taken a distance, that is a 0.05 into 10 raised to minus 3 meter. So put down the values in the formula and calculate. Here tau value is 3 Newton per meter square. Change in velocity is zero point 0.5 meter per second, and your change in distance is 0.05 into 10 raised to minus 3. So you put down the formula, or put down the values in the formula and calculate on in your calc. You will get 0.3 into 10 raised to minus 2 poise. So the viscosity of fluid is 0.3 into 10 raised to minus 2 poise. So in this way we can calculate the kinematic viscosity and dynamic viscosity on your by using the formulas. So thank you for watching, or if anyone have comments, you can share.